to clouds. Okay, recording is in progress. Hey everybody, we're live and in stereo. My name is Mohammad Suleiman Khan, your fun chemistry teacher. Most of you might not be able to call me your teacher because I haven't taught you guys. Some of the students, I can see your names, they are quite familiar, which means you guys have studied from me. Most of you haven't studied from me. But today we are going to be solving an MCQ paper, which is basically the latest MCQ paper, that is October-November 2023, and the variant is 2-1. We're also going to solve 2-2, 2-3, all the variants, all the latest past papers in my past papers session. But this is just like a free session to teach you guys how to go about MCQs, how to solve MCQs, and what should be your mindset. You have 45 minutes for this paper, and it's pretty evident. If you don't know you have 45 minutes, you guys should look right here at the right top. It's not top right, but it's like some middle right hand side of the paper, and it says 45 minutes. It's IGCSE paper, Jamal Kashif Saab. So IGCSE is 45 minutes. Before I start solving the past paper, I just wanted to give you guys a few tips. That is, especially to O-level students. O-level students think solving past papers, especially IGCSE, is useless. Well, you guys are wrong, because IGCSE past papers are very important for O-level students because your syllabus has changed and 99% of the testing is now more like IGCSE, right? So you guys should be practicing latest past papers. There are certain misconceptions as well that, sir, should we be solving? Yes, we will also be solving 5070 papers in my past paper session. So we're going to do both, right? Both are equally important for you guys. But one question I get a lot is that, sir, how many years past papers should we solve? And it totally depends on you guys. The best thing to do is to solve them conceptually, right? So you need to understand each and every MCQ, and you need to understand the crux of each and every MCQ, right? So you need to understand why option A is correct, not just why option A is correct or why option B is correct, but also why the other options are wrong. And that is how you guys can essentially recall all your concepts through past paper questions, right? So are IGCSE past papers better or O-level ones? Both are better. You just have to do the latest ones, right? Do the latest past papers and do all the variants of the latest past papers. Please, it is a request to not go below 2020 if you're solving all the latest past papers. 2020 is more than enough. 2021 is also more than enough. You know, solving all the latest past papers mean that you are solving 11 papers for every session, right? So May June ke 11 papers hain ya 10 papers hain, February March ka bhi solve kare. So sir, my sir said 2013 onwards. It's totally up to you guys. You know, you guys have different gurus, different mentors. I'm talking from my experience. Your teachers might be talking from their experience. Not necessary, right? Because what you need to understand is that the syllabus changes from time to time, and there are certain concepts that are no longer tested, which used to be tested back in 2013 or 2014 or 15 and so on and so forth, right? So without further ado, I'll just write my name. Obviously, my name is Suleiman Khan, like the Britishers say, Suleiman Khan. Yeah. And there are still students joining in. That's not Kurt, man. I think we can't have other students joining because I'll just get distracted, right? So let's start solving the paper now. Okay. And if you guys have questions, you guys can just raise your hands in between and I look at the screen and then I can answer all your queries as well. Yes, Jamal Kashif, I haven't even started and you've raised your hand. Go for it. Go for it. Be quick before I start, because then I slowly gain momentum. And then once you break my momentum, okay, it was by mistake. Okay, then it's fine. Okay, let's start solving the paper, right? So I might solve it in more than 45 minutes because I have to dissect each and every MCQ and essentially explain everything. But you guys should be able to solve this 40-mark MCQ, these 40 MCQs in around 29-28 minutes, right? So it's very easy, it's very simple, and let's start with it, right? So question number 1 says it's October-November 2023/21. The variant is 21, right? 0620. Okay, question number 1 says a gas is placed in a sealed container. So obviously you have a container right here. I'll draw the container. And saying there's like this gas. So if there's a gas in a sealed container, obviously this gas is going to collide with each other and the walls of the container, and it's going to exert pressure as well, right? So that's what's going to happen, because obviously you all should know that from your O levels and IGCSE physics. Then whenever you have a gas in a container, it collides with each other and with the walls of container, and it exerts pressure, right? And if you want me to go into further detail for it, you need to understand that pressure is force per unit area, right? So each gas particle, when they collide with the walls of container, they are going to exert a force per unit area, which is equal to pressure. So we need to get that understanding. So it's saying a gas is placed in a sealed container. The gas has a pressure of 1 atmosphere. Now, 1 atmosphere is basically 101 kilopascals, right? 101 kilopascals equals 1 atmosphere's pressure. And saying the temperature is 50 degrees Celsius. Now, what the examiner is doing is he's saying that it is heated to 100 degrees Celsius, right? So if he's increasing the temperature, what's going to happen? Increase in temperature is obviously going to increase the average kinetic energy of gas particles. Particles are going to move faster, and they are going to collide more frequently with each other and with the walls of container, exerting pressure, right? So that's what's going to happen. And the pressure is obviously going to increase, because the gas particles are going to collide with the walls of container more frequently, right? So you're going to have frequent collisions, and the kinetic energy has increased. So it says which row describes the cause of the pressure of the gas and the effect of increasing temperature on gas. So it says cause of gas pressure: collision between gas particles, collision between gas particles, or collision between gas particles and the container. Obviously, pressure is exerted when there's a force per unit area, right? So they need to collide with the walls of container to exert pressure. So A and B are automatically wrong. You have to select between option C and D. Now let's look at the right hand side. It says the effect of increased temperature on the gas particles. So if you have increased temperature, obviously increase in temperature increases the average kinetic energy of gas particles, which results in more frequent collisions. So collisions become less frequent? No, sir, that's wrong. That's when you have a decrease in temperature. So obviously A was already wrong, but this concept is wrong. Then says the average speed of gas particles increases. Yes, this is wrong, but this option was eliminated because of collisions between gas particles. And then collisions become less frequent? No, sir, collisions become more frequent, right? So the average speed of the gas particles increases. Yes, the average speed of the gas particles increases, and there are collisions between gas particles and the container. So D is the right option. Option number C is also wrong. C is wrong because of this. Collisions become less frequent. No, collisions become more frequent. And that's the first MCQ. How easy it is, man. You just need to eliminate all the options, and your concepts need to be crystal clear. That's it. And you guys are going to see that we are going to solve this entire paper, and we're going to get full marks. Yeah. As long as we're able to eliminate all the other options. Okay. MCQ2 says 4 experiments, each containing a different acidic gas, are set up as shown. The dividing glass plates, blah, 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 blah. In which set of apparatus does the litmus turn red first, right? So you have a damp blue litmus paper, and you have acidic gases. And we know that acidic gases, they turn damp blue litmus paper red, right? So carbon dioxide is going to turn this red. Hydrogen chloride is going to turn this red. And you have nitrogen dioxide, it's going to turn this red. Sulfur dioxide is going to turn this red, because you have acidic oxides, and acidic oxides are essentially your non-metal oxides, and they turn the damp blue litmus paper red, right? So if you look at the options, it says which will turn it red first. First means which is going to be the fastest in reaching this red litmus paper, right? The one that will turn this red first means that it's going to reach it first, right? And reaching it first means that it's going to have a lower relative molecular mass, right? So lower relative molecular mass, let's calculate it. Carbon is 12, oxygen is 16, and 16 times 2, you add them together, and it's going to give you 44 AMU. So that's the mass of carbon dioxide. Hydrogen chloride is 1 plus 35.5. That's basically 36.5. Here you have NO2, lowest relative molecular mass, yes. NO2, N is 14. You guys can check this all in your periodic table. Oxygen is 16, 16 times 2. You're going to get what? What do you get? You get 46. Why am I timing it by 2? Because you have two O's, right? So in order to calculate the MR, it's the sum of the relative atomic masses. So the relative atomic mass of N is 14, of O is 16, and since you have two O's, you times it by 2. And then obviously you have sulfur dioxide. Sulfur is 32 in the periodic table. Oxygen is 16, times it by 2. What do we get? 32 plus 32, that's 64. So the one that's going to turn it red the fastest is the one that's going to have the lowest relative molecular mass, because that means it's going to diffuse faster, it's going to travel faster, right? So which should be our option? Option number B is correct, because that's the lowest relative molecular massarino. Moving on. Question MCQ3 says the group 1 element potassium forms an ionic bond, right? So what is an ionic bond? Ionic bond is basically a type of ionic bonding is the type of bonding in which there's a transfer of electron from metals to non-metals, forming oppositely charged ions held together by strong electrostatic forces of attraction, right? So if potassium forms an ionic bond with fluorine, that means that potassium, since it's a metal, it's going to lose an electron, therefore have a charge of 1 plus, and fluorine, since it's in group 7, it is going to gain that electron, therefore forming a charge of 1 minus. And because they are oppositely charged, they are going to be held together by strong electrostatic forces of attraction, and that is how your ionic bond is formed, right? So if you check the options out, A is wrong because F Cooper, you don't have a plus charge, you have a minus charge. And D is also wrong because F has a minus charge, not a plus charge. And C is wrong because K has a plus charge, not a minus charge. And that's why we end up with B. B is K has a plus charge because it's a metal, it loses the electron. And F has a minus charge because it's the non-metal and it gains that beautiful electron. Moving on, question number 4. Question 4 says X and Y are atoms. X and Y have the same number of electron shells, right? So he's giving us information about X and Y. Same number of electron shells mean that they must be in the same period, right? So if you look at your periodic table, sodium, magnesium, aluminum, silicon, phosphorus, they all have the same number of electron shells, because across a period, you have the electron shells do not change. The number of electrons change, but the shell remains the same, right? But down the group, the shells increase, right? So hydrogen has one shell, lithium has two shells, sodium has three, potassium has four, and so on and so forth. So if he's saying that X and Y have the same number of electron shells, that means they must be in the same period. X and Y have the same number of outer electrons. Same number of outer electrons mean that they must be in the same group, because the group numbers are basically decided based on the valence electrons or the outermost electrons. So all the elements in group 1 are in group 1 because they all have one electron in their outermost shell. X and Y have different mass number or different nucleon number. They basically indicate that they might be your isotopes, right? Because isotopes, they have their atoms, they're different atoms of the same element having the same number of protons but different number of neutrons, or you could say different nucleon number, or you could say different mass number, right? They're essentially all the same thing. And I think which statement about X and Y are correct? X and Y are isotopes. Yes, X and Y are isotopes because they are different atoms of the same element. How do I know they are the same element? Well, it's indicating that they have the same electron shells and they have the same number of outermost electrons, which means that the number of electrons are same. And if the number of electrons are same for an atom, that means automatically the number of protons are also same, right? That's why it's an atom. Every atom is neutral because the number of protons are equal to the number of electrons. Therefore, there is no charge on an atom. So yes, X and Y are isotopes and they have different mass numbers, which means can nucleon number different hai, or you could also say the neutron number is different. So one is right. Number 2 says X and Y have the same total number of electrons. Yes, they have the same total number of electrons. They're atoms, they're not ions. दोनों के outermost electrons are equal, they have the same number of electron shells, so they must have, the total number of electrons must be same as well. And X and Y have the same chemical properties. Yes, sir. Isotopes, they have the same chemical properties, because you need to understand that chemical properties depend on the number of electrons, right? Or essentially the outermost electrons, right? So if you have the same number of outermost electrons, you are bound to have the same chemical properties, right? But because they are isotopes, because the mass number is different, the physical properties are different. So isotopes might have different physical properties, but not different chemical properties. That's the beauty in isotopes. So yes, they have the same chemical properties. So 1, 2, 3, both are correct. All are correct. A should be the right option. Moving on. MCQ5 says lithium chloride is an ionic compound and silicon. Why is it an ionic compound? Because obviously lithium is a metal, chlorine was a non-metal. Said physical properties depend on physical properties for isotopes. You could think that it depends on the mass number, right? So think about it like this, Jamal. You have a fatter molecule. So let's suppose we're talking about carbon. So carbon is 612 and another carbon isotopes is 614, right? So if I talk about the physical property, or not even about carbon, let's talk about like chlorine, right? So chlorine ka ek isotope is chlorine 35 and the other one is chlorine 37. So if I talk about the physical property, like for example, I'm talking about its diffusion, right? I'm talking about how quickly it can move. So chlorine 35 is bound to move faster because it has a lower relative molecular mass, right? So if you have a chlorine molecule made up of chlorine 35 atoms, or chlorine 35 isotopes, it's bound to move quicker. So that basically determines the physical property. Okay. But the chemical properties are the same because the number of electrons are the same. Lithium chloride is an ionic compound and silicon oxide is a covalent compound, right? And obviously the reason for that is that lithium is a metal, chlorine is a non-metal, so it's going to form an ionic bond between lithium and chlorine, which is going to be known as the lithium chloride. And silicon 4 oxide is basically SiO2. It's a giant macromolecule, or you could say it's a giant covalent structure, right? So, or you could also say it's a giant covalent compound. So it says which statement about both the compounds are correct or is correct? They are not soluble in water. No, lithium chloride is an ionic compound, and we've studied that ionic compounds are usually soluble in water. So no, silicon dioxide is not soluble in water, but lithium chloride is soluble in water. And since both के लिए एक statement बताया, you tell us a statement which is true for both the compounds. So A is wrong because lithium chloride is soluble in water. The lattice breaks when you dissolve it in water, and you have ions, right? And that's why it can conduct electricity in aqueous solutions, because you have free moving ions, right? The next bit says they conduct electricity when melted. No, lithium chloride conducts electricity in molten state. Why? Because it has free moving ions. Silicon dioxide or silicon oxide is basically your giant macro molecule. It's a covalent compound, and covalent compounds are poor conductors of electricity. They do not conduct electricity, right? So B is wrong. They do not conduct electricity in solid form. Yes, silicon oxide does not conduct electricity in solid form, in molten form, and whatnot. But lithium chloride also does not conduct electricity in solid form. And the reason for that is that there are no free moving ions. All the ions are involved in, they are held together by strong electrostatic forces of attraction. Ionic compounds only conduct electricity in molten state and in aqueous state, not in solid state. Why? Because in solid state, you don't have free moving ions. So yes, both, they do not conduct electricity in solution. And D says they have low melting points. Huh, my God, ionic compounds have high melting points, and your silicon oxide is a giant covalent structure. It's a macromolecule. Obviously, it has a high melting point. So this is wrong for both. So C is the correct option. Thank you, Osama Zan. You are right. Now, question 6 is which equations are balanced? Now, You just balancing is basically that the number of atoms on the left hand side must be equal to the number of atoms on the right hand side. So if you check all the equations out, you have 2 atoms of iron on the left hand side and 2 on the right hand side. That's balanced. You have 3 plus 3. You have 6 atoms of O on the left hand side, and 3 into 2. You have 6 atoms of O on the right, and you have 3 carbons on the right and 3 carbons on the left. So yes, number 1 is a balanced equation. If you talk about number 2, you have number 2 off the bat is not a balanced equation. Why is it not a balanced equation? Because you have 3 oxygen atoms on the left hand side, but you have 2 and 2 multiplied by 1. So you have 4 atoms of O on the right and only 3 on the left. So because of the O, it's not a balanced equation. And if you check magnesium nitrate, the third equation, it's also not balanced, because off the bat you could see that you have only 1 sodium atom on the left. I don't even have to check all the others, right? I can just skim my way through it. 1 sodium atom on the left and 2 sodium atoms on the right. So that's wrong. The number of atoms aren't equal. And obviously I don't even have to check the other option for me to select 1 and 4, because these are the only options available. But let's check 4. 4 is also a balanced equation. Why? Calcium, there's only 1 calcium on the left and there's 1 calcium on the right, 1 sulfate on the right, 1 sulfate on the left, 1 carbonate on the right, and you have CO2 and O. So there are 3 oxygens and 1 C, 3 oxygens and 1 C. Everything is balanced on the left and right hand side. So 1 and 4 are the correct options. Okay, which row shows the formula of sodium carbonate, zinc nitrate, and ammonium sulfate? Okay, sodium carbonate. Sodium is in group 1, so it'll have a charge of 1 plus. Carbonate is a polyatomic ion or a radical ion, and it has a 2 minus charge. You cross multiply, you end up with Na2CO3. Off the bat, C and D are wrong. Now, if you check zinc nitrate, zinc has a charge of 2 plus, and nitrate NO3 is 1 minus. You cross multiply, you get ZnNO3 whole twice. And therefore, A is also wrong, because the formula is written wrong. Right? So B is the correct option without even looking at ammonium sulfate. But if you want to write ammonium sulfate, ammonium is NH4 1 plus, and sulfate is SO4. What's happening? It's SO4 2 minus. So cross multiply, you get NH4 whole twice SO4. Great, and that's correct. I didn't even have to check this, but yeah. Which statements about hydrogen and oxygen are correct? Okay. Which statements are correct? Let's see. Hydrogen and oxygen can react to produce electrical energy. Obviously they can, and that's why they are known, they are used in hydrogen fuel cells, right? That's the basic purpose of a hydrogen fuel cell. It takes in hydrogen and it takes in oxygen, and hydrogen and oxygen are used to make H2O and to give you electricity. So A and B off the bat are wrong. And you guys need to understand that in your MCQs paper, 2 options are wrong off the bat. Like thodi si bhi agar, even if you have a little knowledge about chemistry and your concepts are just a tiny bit clear, you need to you will be able to eliminate 2 options off the bat. That increases your chances by 50%. What is the type of ion is CO3? It's called a polyatomic ion, yeah, or a radical ion. Okay, so A and B are wrong. Now, hydrogen and oxygen can be made by the electrolysis of dilute sodium chloride. Let's do it, right? So if we perform electrolysis, let's make our electrolysis chamber. Dilute aqueous sodium chloride means you're going to have the sodium ions, the chloride ions, and because it's aqueous, you'll also have the hydrogen ion and the hydroxide ion. That's my positive electrode. That's my negative electrode right here. And if you struggle with the positive and negative in electrolysis, you can use the term panic. Positive is anode and negative is cathode. Now, what's going to happen at the anode, at the cathode? The cathode, the sodium ion and hydrogen ion are going to have a race. The hydrogen ion is going to win the race because it's more reactive than the sodium ion. We're talking about ions here, not the metal, right? So the hydrogen ion is more reactive than the sodium ion. So at the cathode, what's going to happen is 2 hydrogen ions are going to go together. They're going to gain 2 electrons and they're going to give you H2. And at the anode, what's going to happen is between the chloride ion and the hydroxide ion, there's going to be a race. But because it's dilute, the chloride ion is not going to win the race, and therefore the hydroxide ion wins the race. And four hydroxide ions are going to go together, giving you 2H2O plus O2, and they're each going to lose an electron. So in total, four electrons are lost. So if you perform the electrolysis of dilute aqueous sodium chloride, you're going to get hydrogen gas and you're going to get oxygen gas. So that's true. Hydrogen and oxygen can be made by the electrolysis of dilute aqueous sodium chloride. Therefore, D is the right option and C is wrong. Fractions are allowed for balancing. Yes, Jamal, you could use fraction. Yes, Muhammad Awais, go for it, man.
Yeah, I didn't understand this question. Like, why did you choose hydrogen over sodium?
Well, you have to learn electrolysis for that, man. I'll be more than happy to help you at the end of it, right? Because the hydrogen ion is more reactive than the sodium ion. The sodium metal is more reactive than hydrogen, but the reactivity of ions is opposite to the reactivity of metal. So if you know your reactivity series, please stop calling me a careless zebra. You need to understand that the reactivity in the reactivity series, when you talk about potassium, sodium, calcium, blah blah blah, the reactivity decreases as you go down the reactivity series, but the reactivity of ions increases as you go down. That's why when you have copper ions and hydrogen ions in a solution, the copper 2 plus ions are obviously going to win the race, right? So you need to have a little jog of the memory for
I got it.
your
Thank you.
electrolysis. Okay.
I got it. Thank you.
Okay, welcome. Graphite has a giant covalent structure. Which statements, obviously, it has a giant covalent structure, right? So, which statements about graphite are correct? Carbon atoms form four covalent bonds? No, absolutely wrong. No, carbon atoms form three covalent bonds. Four is in diamond, right? And that is the reason why graphite can actually conduct electricity, because it makes three bonds and carbon is in group four. One electron remains delocalized, and that is the reason why graphite can conduct electricity, is because it has delocalized electrons, because each carbon makes three bonds rather than four in like diamond, right? So option number one is wrong. There are delocalized electrons between layer of carbon atoms. Yes, there are delocalized electrons. That's why it can conduct electricity, you dumbo. And graphite is a useful lubricant. Yes, graphite is a lubricant. That is the reason why it's also used in your pencils and stuff like that for smooth writing. And graphite is a good conductor of electricity. Yes, because it has a delocalized electron. So C is the correct option, 234. Which reaction pathway represents an endothermic reaction? Well, you need to understand what an endothermic reaction is. Endothermic reactions are those reactions in which the energy taken in is more than the energy given out, right? So overall energy taken in hoti hai. So if I talk about an endothermic reaction, because we are given a half reaction, I'll explain it in a very easy way. You have reactants, and reactants are going to gain energy, and they are going to form products, right? That's what an endothermic reaction is, right? So you have reactants, it gains energy or takes in energy from the surroundings, and obviously you end up with products. Now if you have reactants and they have an energy of 70 joules, and let's suppose the energy that they take in is 20 joules, the products should have an energy of 90 joules, because law of conservation of energy says that energy can neither be created nor destroyed. It is only converted from one form to another. So you have reactants, they're going to take in energy from the surroundings, and they're going to form products, right? So reactants had, I'm assuming that they had 70 joules of energy, they took in 20 joules, and now the products have 90 joules. So if you understand it like this, you're going to know that the products are going to be at a higher energy level than the reactants. So obviously C and D are automatically wrong, because C and D are indicating that reactants have more energy than the products, and that's wrong. No, the products have more energy than the reactants, and we've proved this right here. And the enthalpy change for endothermic reactions is always going to be positive. So it's not negative 24 kilojoule per mole, it's a positive 24 kilojoule per mole. So B should be the correct option. A is wrong because of this negative. So you guys need to just be able to eliminate all the options, and you guys are bound to get 40 out of 40 in your MCQs. Like, it's so easy. Just make sure you eliminate each and every option. Don't just select an option blindly. Okay. Now, it says hydrogen burns in oxygen and the equation for the reaction is shown. The table shows the bond energies involved. Okay, so you have H2, it reacts with O2 to give you H2O. Now, if you're given bond energies, you just need to draw the displayed structures for it to make it easier for yourself, right? So you have H2, which is H bonded to H, and you have O2, which is O double bonded to an O. Now, in order to calculate the enthalpy change, you have to use the formula, which is bonds broken minus bonds formed. So if I take the bonds broken, which bonds are going to break? Obviously, the bonds of the reactants are going to break. So hydrogen bond is going to break, and you have O2, and you have two H's, right? So 2H2, and then you have O2, which is O double bonded to O, and that is only one. So and bonds formed is basically you have two moles of H2O which are formed. And H2O is O bonded to H and bonded to another H. Okay, that's bonds formed. Now plug in the values from the bond energy table. Hydrogen bonded to hydrogen is basically like your 436 kilojoules per mole. So if I plug in 436 instead of this, I can have 2 multiplied by 436 plus 1 times O double bonded to O, that's 498, right? So 498 is that. So if anybody can calculate this for me, can anybody calculate this for me, plus? What do we get? 2 times 436 plus 1 times 498. What do we get? 1370. Okay, that's 1370. Thanks, Maha. This is the energy taken in during bond breaking. And what's the energy given out during bond formation? The energy given out during bond formation, O is bonded to H, right? So O being bonded to H, that's given right here, 464 kilojoules. So and there are two bonds, right? So this is O bonded to H. Let me highlight it for you. This is O bonded to H, and then this is O bonded to H. So there are two bonds right here. And if there are two bonds, that means you have 464. This 2 is outside, but that's 464 times 2 because you have two bonds, O bonded to H and then O bonded to H. And each O bonded to H, when it forms, O being bonded to H, when this bond forms, you have an energy of 464 kilojoules, which is given out. So 464 kilojoules will be given out here, and 464 kilojoules will be given out here. And since you have 2 moles, you times it by 2 in the end. So what energy do we get? What energy? 1856. Can somebody also confirm it? Okay, great. It's 1856. Now, enthalpy change is what? Enthalpy change is the energy taken in during bond breaking minus the energy given out during bond formation. So bonds broken minus bonds formed, 1370 minus 1856. We get D. Are you sure we get D? No. Do we get D or do we get B? What do we get? 1370 minus 18C. Okay, C. Most
जी
students are
सर
saying
सी
C.
हमारा
Okay. GRS, so minus
आंसर है, हमारा आंसर
486.
सी।
Okay. Okay, great. I'm just solving it with you guys. I don't know. Calculations are up to you. The use of calculators are up to you guys, man. I'm just the brain here. So if you use the calculator wrongly, that's not my fault. Which process involves a chemical change? Now, what is a chemical change? Chemical change basically means a chemical reactionary, right? So whenever there's a chemical reaction, there's going to be a chemical change. And in a chemical change, new products form, right? Mostly new products form. Sir ने मुझे पहचाना ही नहीं. Oh, Sir Ali Abbas is here. Hey, sir, what's up?
जी वो पिछला सवाल का आंसर मैंने दिया था आपको सी।
अच्छा, आपने
अच्छा
दिया
जी
तो देखें फिर सर
जी
सर इस
जी।
कितना कितना फायदा हमें सर का हो रहा है. ही इज प्रेजेंट इन दिस क्लास और उनकी वजह से हमने सी सही ऑप्शन हमने चूज किया.
अच्छा हाउ आर यू
क्या
गाइस, माशाल्लाह सारे मेरे शहजादे बैठे हैं, आई कैन सी अ लॉट ऑफ स्टूडेंट्स ओवर हियर। सर का
दैट्स
फ़ायदा उठाएं,
अमेजिंग.
अच्छा जितना फ़ायदा उठा सकते हैं सर को नचोड़े। मैं हमेशा स्टूडेंट्स को कहता हूँ स्क्वीज योर टीचर्स, ओके, बी लाइक अ स्पंज। जितना सर से सीख सकते हैं सीखें। अच्छा सर लाइक इज़ वेरी नॉलेजेबल पर्सन। अच्छा ये
क्या
सर
बात है.
हमारे भी
थैंक यू वेरी मच सर फॉर
जी
योर
जी
काइंड
जी।
वर्ड्स. सर का भी पास्ट पेपर सेशन शुरू है. सर आर यू कंडक्टिंग एनी क्लासेस बिफोर योर पास्ट पेपर सेशन?
नहीं नहीं, मेरी तो एक हो गई है, कल से इंशाल्लाह पास पेपर सेशन स्टार्ट हो रहा है, फिजिक्स का केमिस्ट्री का बोथ। आई हैव अ लॉट ऑफ
हम्म.
स्टूडेंट्स, इधर भी हैं काफ़ी उसमें। खैर सर से फ़ायदा
दैट्स
उठाएं, शायद सर का जितना फ़ायदा आप लोग उठा सकते हैं सर से पढ़ें, सर के एंड सर को तंग भी किया करें डीएम्स में वीएम्स में। सर जवाब तो नहीं देते, कोई यू कैन ऑलवेज ट्राई। सही है।
you guys can try contacting me my dear.
सर तो मुझे नहीं जवाब देते, आप लोग तो दूर की
नहीं
बात,
नहीं सर,
सर
ऐसी
बड़े
कोई
बिजी
बात नहीं है.
बंदे हैं। खैर
सर
आप लोग
थैंक यू.
पढ़ाई करें, चाहिए एंजॉय, ओके।
Thank you, sir, for your kind words. Chaliye, let's continue. So which process involves a chemical change? As we were saying, chemical change means that there must be a chemical reaction, new products must form, right? So if you check adding sodium to water, think about it. When you add sodium to water, what's going to happen? You must know this reaction. Sodium reacting with H2O, you're going to form what? A base, sodium hydroxide is going to form, and H2 gas is going to be released, right? That is the reaction. So sodium being added to H2O, NaOH forms. So this is a chemical change because obviously there's a chemical reaction taking place. So A should be the correct option. But if you check a B, C, D out, B says boiling water. Boiling water is basically going from H2O liquid to H2O gas. And if you go from H2O liquid to H2O gas, that's just a physical change. That's just this change in, so why did you put 2 inside the bracket in question? Let's go back to question 11 at the end, man, now. Okay, so going from boiling is basically the process of converting a liquid into a gas, right? So you're going from H2O liquid to H2O gas. There's no change in chemical composition of matter. There's no new product being formed and so on and so forth. So if there's no new product being formed, that means there's no chemical change. It is just a physical change. Physical change is basically the change in appearance. So you went from a liquid appearance to a gaseous appearance. So B is wrong. C says dissolving sodium chloride in water. So dissolving sodium chloride in water means you have NaCl solid, namak, that we use in our day-to-day lives, in our biryanis, and you add it to water, then you got NaCl aqueous. So you just changed its appearance. It went from a solid appearance to an aqueous appearance. So C is also wrong. That's not a chemical change. There's no new product being formed. There's no change in chemical composition of matter, blah, blah, blah. Producing water from aqueous sodium chloride. That seems tempting. Producing water from aqueous sodium chloride, which means essentially what you're doing is you have NaCl, which you've dissolved in water. It's aqueous. And now you're heating it up. So the water is going to go out of it and you're going to end up with NaCl solid. So you're basically changing the appearance again. You're going from an aqueous appearance to a solid appearance. So that's basically a physical change, not a chemical change. So yes, we were right. A is the correct option. Moving on. An experiment is carried out to find the rate of reaction between hydrochloric acid and zinc. The results of the experiment are shown. So you have zinc solid reacting with hydrochloric acid, blah, blah, blah. Okay. What is the label on the y-axis? Now, if you check out the y-axis, what's happening? Whatever is on the y-axis, it is decreasing as the time is passing by, which means as the reaction takes place, whatever is on the y-axis, it is decreasing. Now, if you look at zinc chloride and hydrogen, these are the products of the reaction. And you guys would be dumbos if you guys think that the products of this reaction are decreasing. No, products were initially zero. There were no products at the start of this reaction. But as this reaction took place, these products will start to form. So products ke liye, the graph should have been something like this, right? And that's not the case. So on the y-axis, it can't be zinc chloride, neither can it be hydrogen gas. So the amount of zinc chloride produced, that's wrong, and the volume of hydrogen gas produced, that's wrong. The option is between B and C. Now, if you check B and C out, on the y-axis, it must either be the amount of zinc being used up or the amount of hydrochloric acid being used up. And if you check B and C out, it says B and C में अगर आप option देखे, तो आपको बता रहे कि the mass of zinc that reacted and the concentration of HCl. Yes, B is right, the concentration of HCl, because if you check this out, HCl is going to decrease the concentration, the amount of HCl is going to decrease with time, right? So you had maybe 2 mole per decimeter cube of HCl, and as it reacts with zinc, this amount is going. The mass of zinc reacted, that doesn't make sense. Like the mass of zinc react, वो कह रहे कि mass of zinc react जो हो रहा है, it is decreasing. The mass of zinc reacting is decreasing. It's not making sense. So sometimes the MCQ doesn't make sense, right? The option doesn't make sense. Not the MCQ, the option that they give is just so ambiguous, it doesn't make sense, right? The remaining mass, yeah. So it's absurd. That's what C is also wrong. B is the correct option. 14 says hydrogen peroxide. Okay. Hydrogen. Now, if I were you guys and I was solving this in my examination, I would skip MCQ 14 because it requires a lot of calculation, reading. I just move on. I'm also teaching you guys how to go about the MCQs when you're sitting in the paper, right? So if you see an MCQ requiring a lot of reading and a lot of calculations, move on, do all the other simple MCQs. But obviously, since we are doing the past paper here, we're going to solve this MCQ as well. So it says hydrogen peroxide decomposes to form water and oxygen. We're given the equation. Manganese oxide catalyzes the decomposition reaction. Okay, the reaction is investigated in 4 experiments. You're given the volume and concentration of hydrogen peroxide. Now, whenever you're given volume and concentration of hydrogen peroxide, I can absolutely find the moles or the what am I saying? Yeah, the moles of hydrogen peroxide, right? So you're given the volume, you're given the concentration. If you guys know your formula is N is equal to CV, convert this centimeter cube into decimeter cube or this decimeter cube into centimeter cube and find the moles. And if I find that out, you have 1 times 12.5 over 1000. So you're going to get 0.0125 moles here. Here you're going to have 0.025 moles. Here you're going to have 0.025 moles. And here, obviously, you're going to have 0.025 moles. How did you do it, sir? Well, these two are same. And because it's 1 mole per decimeter, 1 mole per decimeter, I just divided it by 1000. You guys can use your calculator. Sir, zinc is still present in the beaker. That is why the mass remains the same. I don't want this MCQ. Zinc is still present in the beaker? No, it does not say that zinc is present, right? It is not specifying which reactant is in excess or which is limiting. Yeah. Okay. So these are my moles. Great. And says all reactions go to completion and all measurements of gas volumes and blah, blah, blah. Okay. Experiment 1 produces less gas than experiment 4, but at the same rate. Let's check it out. Experiment 1 and experiment 4. They have different moles of hydrogen peroxide, which means they are going to make, I don't even have to calculate it. Oxygen is the gas being produced, right? So if you have different moles of hydrogen peroxide, obviously the volume of oxygen that's going to form is obviously going to be different. So either you can do donkey work and start calculating the volume of oxygen from 0.0125 moles and 0.025 moles and use your stoichiometric equation, blah, blah, blah. That's just going to waste your time. You know that the moles of hydrogen peroxide are different. So if you're going to use stoichiometry to find the volume of oxygen, it's also going to be different, right? So experiment 1 produces less gas than experiment 4, but at the same rate. Check out the rate. The condition in 1 is that you have 25 centigrade with degree Celsius with manganese oxide powder, and here you have 40 degrees Celsius. So rather than calculating the gases, rather than calculating the volume of gases, I can just say that the rate is not the same. Here you have 25 degrees Celsius and here you have 40 degrees Celsius. So this must be faster than this one, right? And because the concentration is the same. So this must be fast. This experiment 4 must be faster than experiment 1. So the rate is not the same. Experiment 4 is faster than 1. So A is wrong. B says experiment 2 produces more gas than experiment 1, but at the same rate. If you check experiment 2 and 1, again, the rate cannot be same because obviously here you have a greater temperature than this one, right? Although you might argue that, sir, the concentration is doubling in experiment 2, but you need to understand that the temperature is not doubling in experiment 2, right? The temperature is increasing by 15 degrees Celsius. So the rate can't be the same, right? The rate must be different for both. So B is also wrong. Now, in experiment in option C and D, let's look at D first, because I know C is the right option. I just skimmed through it. D says experiment 3 and 4 each produce the same volume of gas. Yes, they are going to produce the same volume of gas because you have the same number of moles of hydrogen peroxide. So you have the same number of moles of hydrogen peroxide. Obviously, if you use stoichiometry, you're going to end up with the same volume of oxygen, right? So you do have the same volume of oxygen gas that's going to be produced, but it says at the same rate. Let's check this out. Well, in experiment 3 and 4, it says 40 degrees Celsius without manganese 4 oxide and 40 degrees Celsius with manganese 4 oxide. In one experiment, you are using manganese 4 oxide. In one experiment, you're not using manganese 4 oxide. So experiment 4's rate must be faster because you're using a catalyst essentially in experiment 4. So D is wrong. The rate cannot be same. Experiment 4 is faster. So therefore, from my elimination, C is the correct option. And if you check C out, it says 2 and 4 each produce the same volume of gas. Yes, because they have the same number of moles of hydrogen peroxide. And it says, but at different rates. Obviously, it's at different rates because 2 has a concentration of 2 mole per decimeter cube and 4 has a concentration of 1 mole per decimeter cube. So obviously, the rate of reaction is going to be greater in experiment 2 compared to experiment 4, provided, and you guys can see this, that in both cases, the temperature is the same and both are using catalyst. But because the concentration is greater in experiment 2, the rate of reaction is also going to be greater. Hi, this was a long MCQ. Sir, if part B had 50 degrees Celsius, then option 2 would have been correct. Even then, option 2 would not have been correct, Jamal. The reason for that is you need to have a little understanding about rate of reactions. And what you need to understand is doubling the temperature increases the rate of reaction by more than double. And the reason for that is that the frequency of collisions increases and more particles have energy greater or equal to the activation energy. So doubling the concentration doubles the rate of reaction, but doubling the temperature increases the rate by more than double. And that's why you have a general concept that is increasing. Yeah, for every 10 degrees Celsius, it doubles. That's true. But for doubling the temperature, the rate of reaction increases by more than double. Sulfuric acid is produced by contact process. Which row shows the typical conditions used in this process? So which row shows typical conditions? Anybody? Let's do it together. So the catalyst in contact process is not iron, it's vanadium pentoxide. So A, B automatically wrong. And between C and D, let's look at the temperature. We know that the temperature is 450 degrees Celsius, not 300 degrees Celsius. So we're going to select option number C. But let's look at this as well. It says 200 kilopascals and a 20,000 kilopascals. Well, you know that in contact process, you need 2 atmospheres pressure, right? So 1 atmosphere is 101 kilopascals. And here they've rounded it off to 100. So if 1 atmosphere is 100 kilopascals, 2 atmospheres should be X. X is equal to 200 kilopascals, not 20,000 kilopascals, right? ये kilopascals में दिया, pascals में नहीं दिया. So C is the correct option. Which equation shows the reduction of copper? Now, if you want to check out the reduction of copper, there must be a decrease in oxidation state, right? So copper is +2 here, but here it's 0. So yes, 2 plus 2 se aap ja rahe hain 0 mein. So there's a decrease in oxidation state of copper, and therefore A must be the correct option. Sir, how do you know it's +2? Well, I know that oxygen is always going to be -2, right? So if copper is X, I don't know what copper is, but I know oxygen is -2, and I know the overall oxidation state of any compound is 0. So X is equal to +2, right? And on the right hand side, the oxidation state of any substance in its pure elemental state is always 0. Essentially, whatever is written in the periodic table as it is, their oxidation state is 0. Yeah. So is the correct option. I don't even have to look at B, C, D. अच्छा वैसे B, C, D को मैं देख भी लूँ, C और D automatically गलत है because C और D में there's only a change of state. There's not even a chemical reaction that's taking place. Redox or reduction or oxidation is a chemical change. This is just a physical change. So C or D are off the bat wrong. And in B, sulfur is -2 here. So copper is going to be +2. And here oxygen is -2. So copper is obviously +2. So it's not showing that copper is reduced. It's +2 here and +2 here as well. So be thoughtful. That's how you need to do the MCQs, guys. I'm telling you. Which statement about the acids is correct? A weak acid partially dissociates in aqueous solutions. That's true. A weak acid does partially dissociate in an aqueous solution. And the greatest example is your vinegar. Ethanoic acid, right? So A is the correct option, but let's check B, C, D out. An acid accepts proton? No, an acid is a proton donor, not a proton acceptor. Ethanoic acid is a strong acid? Wrong. Ethanoic acid is a weak acid. Hydrochloric acid is a strong acid that ionizes in water to form the H- ions. No, it forms the H+ ions. So see, we can't be fooled by Cambridge. We know our concepts. Easy peasy lemon squeezy. Copper 2 sulfate is formed by reacting excess solid copper 2 carbonate with dilute sulfuric acid. Copper 2 sulfate, well, you need to understand that it's the formation of a soluble salt. Copper sulfate is a soluble salt, and it's other than group 1. So it must be prepared through an excess method, right? And in excess method, what we do is we take your copper carbonate, in this case, is this chunk of copper carbonate that you take, and you add sulfuric acid to it, right? So we are going to add sulfuric acid to it. And once you add sulfuric acid to it, sulfuric acid is going to be limiting, and your copper carbonate is going to be in excess. The reason for that is because it's easier to remove copper carbonate from this reaction. So the copper carbonate would have been reacted with the sulfuric acid, and you are going to end up with a copper sulfate solution, and a little bit of copper carbonate would be left behind because you have added that in excess. So to remove this copper carbonate, to separate the copper carbonate solid from the copper sulfate, then we perform filtration. So you perform filtration, the copper carbonate is going to be stuck here, right here, and your copper sulfate is going to come right here. And then obviously, because you need solid crystals of copper sulfate, you are going to pour this in an evaporating dish and heat it till the point of crystallization. So that is the entire process of making this salt. So it says, which processes are part of preparation of solid copper sulfate? We already discussed the entire process. So you do have crystallization at the end. There is no distillation, man. Distillation किधर से आ गई, मतलब मर्जी वाली बात है. Distillation. And obviously you have a filtration as well, because we are separating this copper carbonate excess which was left here, that is obtained as our residue, right? And there is no titration. Titration takes place in making group 1 soluble salts, not other soluble salts. So 1 and 3 are correct, and therefore A is the correct option. Moving on. Which type of reaction is presented by the equation shown? Well, you're given this scary looking equation. Just make a beaker and add all of them together, right? So if you make a beaker and add all of them together, you have the lead 2 plus ions, you have the nitrate ions, and you have like the sodium ions and the iodide ions. And if you check the right hand side out, you have lead iodide being formed, which means that you took two soluble salts and you added them together. And when you added them together, you added them to water, and then you added them together. And then obviously this lead ion comes into contact with the iodide ion, and it forms a precipitate, which is basically a yellow solid that forms, right? So this is essentially a precipitation reaction. It's making it's basically the formation of an insoluble salt. So an insoluble salt is being formed, which is lead iodide, and sodium nitrate is left behind in the solution as it is. So that's sodium nitrate that's left behind, and this is a precipitate that's formed. So it is a precipitation reaction. It's not an addition reaction. And the addition reaction to alkenes mein jaake humne padha tha, right? So it doesn't make sense. Redox reactions, those of you, it's not a neutralization reaction, because neutralization reaction is H plus OH minus gives you H2O. That's the neutralization reaction. So C is also wrong. Those of you who think it's redox, well, you dumbos, check out the oxidation state. Lead is +2, nitrogen is +5. You guys can calculate it for yourself. This is -2, this is +1, this is -1, this is +2, this is -1, this is +1, this is +1, this is -2. The oxidation states remain the same. From left hand side to right hand side, there's no change in oxidation states. So it's not a redox reaction either. It's D. Which compound is likely to be colored? Well, it must be a transition metal. It must be a compound from transition metal, because that's the property, right? So it's potassium nitrate, no. Potassium carbonate, no. Potassium sulfate, no. KMNO4, potassium manganate. Because of the manganate ion, this is actually purple, and you all know that it's purple, right? We've used this in so many places. Which statements about metal zinc is correct? Okay, metal zinc. Oh my God, I'm so tired. Okay, it's extracted from the ore bauxite. Bauxite? Zinc is bauxite? What? Cambridge, what are you doing? Do you think we are stupid? Bauxite is aluminum oxide ore. Al2O3, man. What is wrong with you? Zinc is extracted. Zinc ka ore jo hota hai, that's basically zinc oxide, right? And how do you come up with zinc oxide? Basically, you have zinc blend, which is zinc sulfide. It's just extra information. So you have zinc sulfide, you react it with oxygen, you get zinc oxide, and then you reduce it with carbon. Okay, it is used to galvanize steel. Yes, it is used to galvanize steel because you studied the concept of your galvanization and sacrificial protection. Galvanizing kya hoti hai? It's basically coating a layer of zinc on top of iron or steel. Why am I saying steel? Because steel also has a certain percentage of iron in it, right? So you want to prevent that iron from rusting. That's why you coat it with zinc. So yes, you do that. And it is used to make alloy brass. Brass is made from zinc. Let's check it out. The way I remember this is I write brass and I write bronze. Let's check this out. So brass and bronze both contain copper. One has zinc and one has tin in it, right? So brass has less letters or less alphabets. So obviously to compensate for that, we are gonna write zinc here, and bronze has more alphabet, more alphabets here. So I'm gonna write tin here. That's how I've memorized. You essentially need to memorize it. So brass, it is used to make the alloy brass. Yes, it is. It is. Yeah. And it says it reacts with dilute hydrochloric acid to produce hydrogen gas. Obviously, it does because zinc reacts with HCl, NeMed, because it's more reactive than the hydrogen in the acid. It's going to form zinc chloride plus H2 gas. So 2, 3, 4, C is correct option. अच्छा सबकी एनर्जी आहिस्ता आहिस्ता डाउन होती जा रही है स्टूडेंट सारे लीविंग आहिस्ता आहिस्ता थक रहे हैं घंटा हो गया यार व्हाट इन द वर्ल्ड वी आर टेकिंग सो लॉन्ग लेट्स स्पेस अप Acha, which elements are unreactive monatomic gases? Monatomic gases and unreactive monoatomic. So it's basically talking about your group 8. Group 8 is basically your noble gases, right? ये time ठीक नहीं है. Acha, we're gonna see something. We're gonna do something about it. Okay. So 2, that is a complete octet. That is basically your helium. It is a monoatomic gas, right? And it's unreactive because it's a noble gas. So 2 is correct. 2 comma 2, no, it does not have a complete octet, does not have a complete octet. Yes, S has a complete octet, and 2, 8 is basically your neon. That's my neon. So P and S, B is the correct option. Moving on. Which row compares the strength of alloys with pure? Alloys are stronger than pure metals, and that's the entire concept of alloys, man. So weaker, A and B are wrong. An explanation is the larger atoms slide more easily. If they slid more easily over each other, that would have meant that there is less friction, and then they would be more malleable, and they would be more ductile, and they would not be stronger. So that's wrong. That's wrong. They wouldn't slide easily, man. Come on, what's wrong with you? So C is also wrong. The larger atoms make it harder for layers to slide over one another. Yes, they disrupt the regular structure of the lattice, and now the layers no longer slide over each other, or it makes it difficult for the layers to slide over each other, and therefore it's stronger. Zinc oxide reacts with carbon to produce zinc. Which equation represents this reaction? Well, you have multiple reactions here. You just check out the balancing. Check out the balancing. Which option is correct? Check it out. In the first equation, you have one oxygen on the right hand side and you have 2 oxygen atoms on the left. So A is wrong because it's not properly balanced. Check out B. If you check B out, 2 oxygens on the left hand side and you have 2 times 2, 4 on the right. So B is also wrong. If you check C out, 1 oxygen on the left, 1 on the right, 1 zinc, 1 carbon, 1 carbon. C is the correct option. It's a balanced equation. Yes, sir. And if you check D out, in D you have 1 oxygen on the left and 2 times 2, it's 4 on the right. So it's not a balanced equation. Right, when a piece of aluminum foil is added to dilute hydrochloric acid, no effervescence is seen. Now, this is a good question. No effervescence is seen means that there's no reaction taking place, right? And whenever we know that aluminum reacts with hydrochloric acid to give you aluminum chloride plus hydrogen gas, right? But in this case, it's saying that effervescence nahi nazar aa raha. So what must be the reason for it? Aluminum does not make a gas when it reacts with acids. That's scrap. It does. We know it does. I don't know why it did not make effervescence. Let's check out the options. Aluminum is less reactive than hydrogen. Absolutely wrong. Aluminum is more reactive than hydrogen. C is not the correct option because aluminum is more reactive than hydrogen. We all know that. That's why it can displace or replace or displace the hydrogen in the acid to give you aluminum chloride and hydrogen gas. Aluminum only reacts with concentrated acid. We've not studied any concept like this. The only option is that aluminum has a surface layer of its oxide. Yes, and that is what prevents it from corroding as well, right? So who are ye? You know, if you think about it logically, what might have happened is that when you were adding the aluminum foil to it, it reacted with oxygen beforehand. So aluminum reacted with oxygen beforehand to give you aluminum oxide. And this aluminum oxide actually prevented, now, like you have aluminum foil here, and there's this layer of aluminum oxide which prevented it from reacting with this acid. So that is what might have happened. Iron nails are stored in an airtight container. The nails begin to rust after a few days because there's air in it. Air contains water vapors, which is H2O, and it also contains oxygen gas in it, right? And for rusting, for zung, you need H2O and O2. So it says the nail begins to rust. Obviously, it's going to rust. It says, how can the rusting be prevented? Leave the lid off. If you leave the lid off, that's so stupid. There's still going to be air outside. So A is wrong. Replace the air with argon. Yes, if you replace the air with argon, you're no longer going to have O2, right? You're no longer going to have oxygen in it. And even if you have oxygen, you're no longer going to have H2O in it. So if you remove any one of these, rusting is not going to take place. So B is the correct option. It says, put the container in a warm place. Nothing is going to happen. Rusting may even take place faster. Seal the container in a bag. That's so stupid, man. What are these options? If you seal the container in a bag, nothing is going to happen. It's still going to rust. 4 substances present in the blast furnace during iron extraction are listed. Calcium carbonate, carbon dioxide. Which substances are both reactant and product? This is a good MCQ. Which substances are both reactants and product? For this, you need to know the entire reaction of your blast furnace, right? So in a blast furnace, what happens is carbon reacts with oxygen to give you carbon dioxide. This is a highly exothermic reaction due to which the calcium carbonate thermally decomposes to form calcium oxide plus carbon dioxide. And this further results in carbon reacting with carbon dioxide to give you carbon monoxide. And obviously calcium oxide is formed and you have sand. So if you have sand in it, because iron's ore is hematite, right? And you find it in mountainous areas, so it's also going to have impurities like SiO2. That is the reason why we add calcium carbonate in it. So it's going to react together and it's going to form like your calcium silicate, which is slag. And obviously this carbon monoxide is going to reduce the iron in hematite, right? So this hematite that you have, iron 2 oxide, is going to be reduced by carbon monoxide to give you iron plus carbon dioxide. So these are all the equations. Now let's check out which are both reactants and products. Well, carbon, if you check this out, carbon dioxide is a product in this case, and it's also a reactant. So carbon dioxide is one of the option. Calcium carbonate, no, calcium carbonate is just a reactant. It's not a product. Nowhere, it's not being formed anywhere. So one is not correct. 3 says carbon monoxide. Carbon monoxide is only a product right here. It's not a reactant, right? So carbon monoxide is, oh, no, it's also a reactant here. Carbon monoxide reduces the iron oxide, right? So carbon monoxide reduces the iron oxide. Carbon monoxide is formed here. So yes, it's also a reactant and a product. Iron oxide, it's just a reactant. So that's wrong. So 2 and 3 are correct. C is the correct option. Sir, आज आपने वो syllabus भी confirm करना है या बस past papers? Just past papers, man. Okay, aluminum is extracted from purified bauxite by electrolysis. Which row shows the half equations? Well, anode is positively charged, is the positive electrode, sorry, connected to the positive terminal. Cathode is the negative electrode. So at the positive electrode, obviously the negative ions are going to be attracted. Unlike charges attract, like charges they repel. So A and B are automatically wrong. And between C and D, you need to understand that if I just look at the cathode to make things easy for myself, aluminum 3 plus ions are going to gain 3 electrons and become aluminum, right? So that's true. Not the aluminum metal is going to give you aluminum 3 plus ions. No, the entire idea is to extract aluminum. Here he's saying you already have aluminum and you're getting aluminum 3 plus ions from it. That's so stupid. You have the aluminum 3 plus ions, they gain 3 electrons and makes aluminum. And obviously it's also confirmed from this case that you have 2 oxide ions, 2 O2 minuses, and each O2 minus loses 2 electrons. So in total 4 electrons are lost. Which test is used to show that the sample of water is pure? Now, which test do we use for sample of water being pure? Evaporate the water to see if any solid remains. That's not a test, man. That doesn't indicate the purity. What if you have ethanol in water, right? So it's going to evaporate beforehand. You take a sample from it, or sharab aapne pani mein dali ho, you're going to take a sample of it, ethanol evaporates beforehand. That doesn't prove anything. No solid is going to remain. Heat the water to check its boiling point. Yes, you check purity of substances by looking at their boiling point, because every substance on the face of planet Earth has a sharp boiling point, right? So you can check their purities. If it is impure, then it's not going to have a 100 degrees Celsius boiling point. It's going to have a boiling point greater than 100 degrees Celsius, right? Because if you add an impurity, the boiling point increases and the melting point decreases. So B is the correct option. And if you check C and D out, test with anhydrous cobalt chloride. No, testing with anhydrous cobalt chloride does not, it is a test for water. It's a test for the presence of water. It's not the test for purity of water. If you add cobalt chloride, it changes color, right? It goes from blue to pink. That means that water is present. That does not mean that it's pure, right? If you take muddy water and add cobalt chloride to it, anhydrous, it's going to change color and it's going to tell you that water is present, right? So C is wrong. This is universal indicator paper to check its pH. Again, universal indicator paper gives us a pH, gives us a color over a range of pHs, right? So how green it is, how not green it is. What if the water is 6.988? It's still going to show you a green color. So it's not pure. 30 says, catalytic converters in car exhausts change polluting gases into non-polluting gases. Which statements about oxides of nitrogen in car engines are correct? Obviously, catalytic converter takes the nitrogen oxides and like the carbon monoxides and converts it into nitrogen and carbon dioxide, right? Now, the nitrogen in oxides of nitrogen comes from compounds in gasoline. No, you dumbo. Gasoline is basically an alkane. Your petrol, gasoline is just a fancy way of calling petrol petrol. So petrol is an alkane, and alkanes are hydrocarbons. Hydrocarbons are compounds with only carbon and hydrogen atoms, not nitrogen atoms. So one is wrong. The oxygen in oxides of nitrogen comes from the air in the car engines. The oxygen in oxides of nitrogen comes, yes, the oxygen does come from the air, right? So you have nitrogen, which also comes from the air, and you have oxygen, which also comes from the air. And because of the high temperature in a combustion engine, they react together to give you nitrogen oxides and nitrogen dioxide. So 2 is correct. Catalytic converters convert oxides of nitrogen into nitrogen. Yes, I just showed you. And it uses rhodium and or platinum, whatever you like. So 2 and 3, B is the correct option. The structures of two molecules X and Y are shown, which describes X and Y. Are they structural isomers? For these two to be isomers, they must have the same molecular formula but different structures. And off the bat, I can see that they do not have the same molecular formula. So isomers ki to baat hi khatam ho gayi. Why? Because 1, 2, 3, 4, 5, 6, 7. This has 7 carbons. 1, 2, 3, 4, 5, 6. This has 6 carbons. So they cannot be isomers, because for isomers, they must have the same molecular formula. Then we look at the structures, right? The structures must be different, but the molecular formula should be same. They don't have the same molecular formula because the carbons are different. And then obviously, do they belong to the same homologous series? Yes, they do, because you have carbon double bond. They both belong to alkenes. So yes, B is the correct one. They both have the same functional group, right? What is the structure of butanoic acid? But means 4 carbons. So 1, 2, 3. This is 3 carbons, and it's not butanoic acid. It's basically it's basically propanol. It's the alcohol bit, right? Again, this is alcohol. This is meth, eth, pro, but. This is butanol, not butanoic acid. This is meth, eth, prop. This is propanoic acid, not butanoic acid. This is meth, eth, pro, but. Yes, this is my butanoic acid. Moving on. When a mixture of methane and chlorine are exposed to UV light, methane and chlorine are exposed to UV light, you're going to end up with CH3Cl plus HCl. Why? Because the hydrogen is going to be substituted by one chlorine atom, and the hydrogen that has been substituted will react with this chlorine atom, which is left behind, to make HCl. That says, it is an addition reaction. No, it is a substitution reaction. The ultraviolet lights provide the activation energy. Yes, it does provide that activation energy, because we know alkanes are generally unreactive. An equation for the reaction is CH4 plus Cl2. No, that's not the equation. Both the hydrogens are not substituted at the same time, right? That's a false concept. And you're going to learn more about this in A levels, which is called free radical substitutions. Who cares what it is? Who cares what it is now? But both hydrogens cannot be substituted at the same time. One hydrogen is substituted, and that hydrogen which is substituted makes HCl. So this reaction is false. And CH3Cl is made in the reaction. Yes, it is. We've just written it down. So 2, 4 are correct. D is the correct option. Esters are formed when carboxylic acid react with alcohol, and you also have a catalyst, which is concentrated sulfuric acid. What is the catalyst for this reaction? I already said it, sulfuric acid, C. Aqueous potassium manganate, no. Iron is in Haber process. Vanadium pentoxide is in contact process. Moving on. The diagram shows part of polymer. Which diagram shows the monomer from which this polymer is made? Put a cut after every 2 carbons. Between 2 cuts, you're going to have your monomer, right? So meth, eth, it's made from, this is basically polyethene. So it's going to be made from ethene as the monomer. Check it out. This is methane. This is ethane. This is meth, this is ethanol. No, there's no O. Such stupid options. Like, why do you think we're stupid? We're gonna select this. C is the correct options. It's made from ethene because this is polyethene, right? So ethene is the monomer. Nylon and PET. Nylon is a synthetic polyamide and PET is a synthetic polyester because of the ester linkage. Which statement about these polymers are correct? They are both condensation polymers. Yes, they are both condensation polymers. They're both synthetic condensation polymers, right? Before I look at 2, let's look at 3. It says the complete combustion of both polymers gives 2 products only. Now, students who have learned this, that whenever you have combustion, there's going to be carbon dioxide and water. Oh, you dumbos, combustion ki definition. Combustion is the burning of fuel. Nylon and PET are not fuels. So they're not going to give you only 2 products. They're going to give you, because nylon has nitrogen in it, it might give you nitrogen oxides and so on and so forth. So please, don't mistake this with fuels. Combustion is of fuels, not of nylon and PET. So combustion of fuels are going to give you carbon dioxide and water. Burning something like plastic, if you burn plastic, it's going to give you other toxic gases as well, right? Not just carbon dioxide and water. So 3 is wrong. Now, now let's look at 2 as well, because then now this is good, right? Because they've also given us an option of 1 only. This is going to be fun. Now, it says OH, CH2, 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 OH could be a monomer for both polymers. Let's draw it. OH, CH2, 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 OH. This can be a monomer for both polymers. Basically, what they've done is they've enlarged that box that we make. This is the box. So it's basically a diol. He's giving you guys a diol, and he's saying that the diol can be a monomer for both polymers. No, sir. Nylon is made from dicarboxylic acid and diamine, not from diol. It is a monomer for your PET, because PET is made from dicarboxylic acid and diol. Nylon is made from dicarboxylic acid and diamine, not a diol. So this is wrong. 1 only is the correct option. Which equation shows the complete combustion of ethane? It's just a balancing question, you know. Pehle C and D are automatically wrong. Why? Because this is ethene, not ethane. He's saying ethane ka bataye. And you balance it out. Here you have 14 oxygens, and 4 times 2 is 8, and 8 plus 6 is 14. And you have 12 hydrogens here and 12 hydrogens here. So A is the correct options, right? A is all balanced. If you look at B, you have 10 oxygens here, but you only, and you have 10 oxygens on the right hand side as well. You have 4 carbons, you have 12 hydrogens, and you have 12. Am I missing something? Am I missing something? Wait. What am I missing in B? Oh, it says complete combustion. Complete combustion. Yeah, A is the correct option because it's saying complete combustion, not incomplete combustion. In B, the problem is it's giving you carbon monoxide. In complete combustion, you end up with carbon dioxide and water, not carbon monoxide. Yeah, that was crazy. Okay, moving on. The painkiller paracetamol. I just took a paracetamol, man. Panadol is basically paracetamol, right? So it says chromatography is done on an impure sample of paracetamol. The results are shown. The diagram is not drawn to scale. The sample of paracetamol is contaminated with, okay, see, if it's contaminated with 4-aminophenol only, what is the RF value of that aminophenol? He's saying कि वो contamination की RF value क्या है? Very easy, man. He's given you the key as well. This is P is pure paracetamol. So if this is pure paracetamol, this is the pure substance that was present in L. This is the impurity. This S is basically the impure sample, right? So in this S, since this is coinciding with P, that means ye dono wo pure cheez hai. But that's the impurity that is present because it's not coinciding with the pure sample, right? So we have to calculate the RF value of this impurity, which is the distance covered by the component. RF value is the ratio of distance covered by the component, which is 2.60 centimeter, to the distance traveled by the solvent front. So that is basically 3.5. So if you calculate this right here, 3.5. Baseline se solvent front. Baseline se either. What do we get? 2.6 divided by 3.5. We're almost there. Javans, we're almost there. What do we get? C is the correct option. Are you sure? C? Okay. If you say so, the equation for the reaction of aqueous calcium nitrate and aqueous sodium hydroxide is shown. Which process is used to remove calcium oxide from the mixture? Well, calcium hydroxide. Calcium hydroxide is a solid. This is aqueous. How do you remove a solid from aqueous? By filtration. Perform filtration. This calcium hydroxide will be obtained as residue, and sodium nitrate is going to be your filtrate. So perform filtration. Chromatography, stupid. Crystallization, stupid. Distillation, stupid. Class nahi khatam hue. Last MCQ. The results of two tests on aqueous compound X are shown. Warm with aluminum foil and aqueous sodium hydroxide, and ammonia is produced, which means this is the nitrate ion. This is the test for nitrate ion. You warm it with aluminum foil and sodium hydroxide, and it gives you ammonia. The test for nitrate, right? Aqueous sodium hydroxide gives you a brown precipitate, which means when you test it with aqueous sodium hydroxide giving you brown precipitate, that's basically the iron 3 plus ions. So what is X? It has the iron 3 plus ion and the nitrate ion. So Fe3 plus and NO3 1 minus. Cross multiply, get FeNO3 whole thrice. Yes, sir. So that's gonna give me iron 3 nitrate. A is the option. It's not iron 2. Iron 2 gives green precipitate. This iron sulfate, the test for sulfate is not this. The test for sulfate is acidify with dilute nitric acid and then add barium nitrate aqueous to it, and you're gonna end up with white precipitate. Boom. Done, guys. Any questions? We started off with a lot of people, but we are only left with the soldiers who persevered through it. Sorry for the long MCQ discussion. I'm so sorry for it. I just had to explain each and every MCQ to you, right? Now, you guys doing this past paper, it should take you less than 30 minutes because there are so many options that you can just go bam, 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 without calculating and giving it. So, because I had to give you guys explanations to it, right? There's no point in me circling options and saying, oh, this is correct. Yeah, this is correct. Then there's no point in that past paper session, right? So you guys revise your entire. That's the basic idea of attending past paper sessions, right? The basic idea of attending these sessions is to revise your entire concepts by attending past papers, right? Or by solving them. If you guys just look at the MCQs, or if the teacher who's solving this past paper just looks at the marking scheme and starts circling options which are correct, it's not going to revise anything for you guys. That's why it's going to take time when I'm solving it. But when you are solving it, it shouldn't take any time, and it should be done in 30 minutes. Could you repeat question 11? Sure, I will repeat question 11 for you, but I'm going to stop the recording. All our options are correct, 100%, no doubt in it, because we eliminated all the options. So you guys can check with your marking schemes, but I am sure, the king is always right. And I'm going to stop the recording here. Those of you who want to stay just for a little gupshup, you can. The others can leave, yeah? The others can enjoy. Okay, I'm going to stop the recording. I'm gonna stop the recording. Do. Okay. How do you stop the recording? Yeah, stop recording.